Let me explain again the question you just asked. Actually, this is the Docker 01 host. This is the Docker 02 host. They are connected via a VXLAN network, similar to OpenStack. Let me address a question one of the attendees asked. For instance, these containers, like the Webs01 container and the Webs02 container over here, communicate across hosts. They actually use a VXLAN network. These two nodes are connected through a network card using VXLAN. Does your Webs01 access Webs02 over here via the VXLAN network? It uses the VXLAN network. It's essentially the same as OpenStack. If these are two compute nodes in OpenStack, remember the compute nodes? This compute node, if my tenant network is a VXLAN network, my cloud machine communicates with this cloud machine using the VXLAN network, right? Often, why not use NAT conversion? Why not NAT? Because NAT conversion is too inefficient. If every connection had to be converted to this address and then converted back to this address upon arrival, it definitely wouldn't be as fast as direct encapsulation access via VXLAN. NAT is too inefficient. So definitely we won't use NAT conversion. That would be too slow. So we directly use the VXLAN network. If there are multiple hosts, all use VXLAN to connect, to enable communication between containers across hosts. That's how it works. This is the principle of container communication. By default, if you haven't set up VXLAN, if you haven't implemented that network plugin, you can't achieve cross-host container communication. You'd have to use NAT. Using NAT means it's unrelated to our container network communication. It's just using NAT. NAT just does address translation, right? Then the communication between them doesn't matter anymore. We access each other via an internal network. You use NAT, which already goes through the external network. Like if I'm in the same classroom accessing your machine, I'd have to go through the external network to come back to you. Isn't that too inefficient? So aren't we supposed to communicate within a local network? Right. All right, that's all for this topic. We'll stop here. Okay. Next, we'll start discussing images, container images. Actually, we also touched on this topic this morning. Now let's focus on this. We've roughly discussed this content over the past few days. All right, let's take a look together. A container image is a template for containers. We've already learned that all our containers are deployed using this container image. It's like a template. A container is an instance of an image created by reading the data from its image template. It's loaded into our container during runtime. Runtime is when containers are created based on the container image. The container image is mounted in the container's root directory. It provides a file system that serves as an isolated execution environment for applications within the container. That is to say, the container image packages the entire operating system and directory. Of course, this includes the application itself and all its dependencies needed to run. Everything is encapsulated within the container image. This ensures consistency between the local and cloud environments. How do we understand this? It means your container has already packaged the files of the operating system and the application you need. If one day I pack this container up and transfer it to another machine to run, it would still work, right? Because the container already contains all the environments it needs to run. So it's easy to export from any machine and import into another machine. And it will run without any differences. So if you deploy a container in the public cloud, and move it to our physical server, or make a container on a physical server and move it to our public cloud, the environments are consistent. The environments are consistent. It's what we often talk about, our test environment and production environment. If we used to run applications on physical servers, we tested them on physical servers without issues. But at the client site, you find they fail to run. There are always various inconsistencies, but containers solve this problem by abstracting away the underlying differences. But containers have solved this issue by masking the underlying discrepancies. All right, all containers share the host machine's kernel. As I've mentioned before, we split it into kernel space and user space. So no matter your operating system, whether it's Debian on this machine, or Ubuntu, or CentOS, at the underlying level, it's the same. Let's take a look here. For example, 95F. You see, uname R is used to check the kernel version. Obviously, it is a Debian system. But it uses the host machine's kernel. Look, this is our host's kernel, and this is our container's kernel. Also look at the partitioning scenario. Our root partition is 50 GB. When you enter this container, you see it also appears as 50 GB, but it uses an overlay file system. We'll discuss this later. So it actually utilizes the same resources as the host. Using the same resources as the host machine, all containers share the host's kernel. If your application strictly depends on the kernel or on a specific kernel version, then it's not suitable for running in containers. Running on a virtual machine would be more appropriate, because if you run 10 virtual machines on the host, each virtual machine can have a different kernel, which is not possible with containers. Containers are used to run applications, focusing more on the application layer itself and not concerned with the kernel, and cannot modify the host's kernel, right? Containers use the files inside the container image using the host's kernel. That is, using the files inside the container image using the kernel on the host machine. And the image cannot be modified and cannot exceed 188 layers. It's about layer management, not exceeding 188 layers. This is the same with Huawei's linked clone. Doesn't linked clone represent an image? At most 188 linked clone virtual machines. When it exceeds 188, doesn't it automatically copy an image? Good. So, introducing the concept of layers and multiple images. Every step in the image-making process generates a new image layer. So you see, this actually represents the process of making images. Originally also generated 4 layers. This image itself has 4 layers, called read-only layers. You see RO, read-only, and moving up is called RW. That is the read-write layer. This is also your container layer. Your container resides in this layer. Suppose you want to modify a file here, or add a new file. It will be written in this container layer. All right, create a new file. New files can only be added in the container layer. Deleting files actually just marks them for deletion. It's obscured, but not deleted from the image itself. Just the pointer is removed. So deleting files doesn't actually affect the image itself. Modifying files, by default, it searches from top to bottom. What does this sentence mean? After finding it, it copies the data from the image layer to the container layer for modification, searching from top to bottom. How do we understand this sentence? Let's say, for example, this is the first layer. This is the second layer of the container, the second layer of the image, the third layer of the image. Originally, I had an index table. This is in the first layer. Later, when making the image, in the second layer, I already modified this file. Actually, if there are ABC3 files here, I modify them in this layer. It will be copied to this layer. All right, when I get to this layer, I might also copy the index file here. It might became BDE. So when you look at the container layer, you actually see BDE. So when you read files, you read from top to bottom. From top to bottom, that is to say, I am now using a file as an example. There might be other files here too. A1, A2. All right then, I just gave an example. You might find it like this. The first index. All right, the second layer. Actually, I added a new file called A1 here. The third layer. I added another file, A2 here. So it reads from top to bottom. When this file, I read it here. And if this file hasn't changed, it's actually a pointer pointing here. An A1 is actually a pointer pointing here. Only A2 is still in its own layer, right? It's read from top to bottom, right? Right? If this thing is in this layer, it reads from this layer. If not, it uses a pointer to find the next layer. Similarly, if this file has been changed by you ultimately, isn't it also read from this layer? So, reading the topmost layer, right, called reading from top to bottom. All right? So, according to the container's layered structure, it searches from top to bottom. Once it searches, it's done. So, to implement this feature, we have some technologies. For example, one of them is called UnionFS, a union file system, where each image layer is part of the operating system's files and directories. In use, multiple image layers are united and mounted on a single mount point, appearing as a complete content operating system for container use. That is to say, it's actually that fusion layer from this morning called long-awaited. That is, ultimately, the container actually goes through multiple layers of changes. Ultimately, is it not integrated into a unified layer? To us, that's what it means. Actually, it's layered underneath. Besides this, we also have another file system called AUFS that can also do this. That kind of file system is just like we are in the link cage. We implemented this feature. We use OCFS2. Huawei calls it VIMS. This kind of file system supports layered structure. We also have one called AUFS that can also achieve a layered structure. You see, it can also be layered. At the same time, we have another called overlay. FS Overlay FS is a union file system similar to AUFS. It's simpler to deploy than AUFS and performs better. So Overlay FS addresses this. It calls the image itself made up of two layers. Is not our DRFF just our container layer? Isn't it finally integrated into the layer seen by the user? That is to say, today you see walkDR user side is not visible. Today, in fact, we are from the image layer. Linked clone layer is that wipe disk. Wipe disk is not then added up to finally integrate into a result. It's just what we talked about this morning. 1 plus 2, right? We see it as 1 and 2. This we cannot see. So you see this file A, this is the image. This is our own file A in the image file C. Later here, actually, I changed it. Just like when I was making the image, I changed it and added a new file B here. Added a new file B. Added a new file D, right? I changed file B here. I also added a new file 1. File 1 is stored in this layer. File D is B, and DB is also here. B was modified here. So B and D are saved in this layer. File A was also modified here, and a new file B was added here. A new file D was added. So A, B, D are saved in this layer. A, C are saved in this layer. Ultimately, the user sees files A, B, C, D, E. Actually, these 5 files, aren't they read from top to bottom? Isn't A read from here? Isn't B read from here? Isn't C read from here? D is read from here. E is read from here. Ultimately, creating a unified file system for external use. So by default, because OverlayFS is simpler and has better performance. So by default today, our Docker uses OverlayFS, and specifically the 2nd generation called Overlay 2 file system. So you see, our driver uses the Overlay 2 driver to provide the file system. So in your container mount, look, when mounted inside isn't the file system type overlay. Implemented layering called overlay. So next time someone asks if you know what overlay is, you say, I don't know. I haven't studied. I have studied it, huh? Today, we can implement layering using a file system called OverlayFS to achieve. It implements a function like this, right? Currently, there are 2 drivers, one called Overlay, another called Overlay 2. We recommend using Overlay 2. That's how it is. Ubuntu by default uses Overlay 2. We split OS. You see, we default use Overlay. Ubuntu uses Overlay 2. So why today? Many containers prefer to run on Ubuntu, run on Debian. Because Debian and Ubuntu perform better in this regard compared to CentOS. Their performance is better. They do better in terms of driver knowledge. So many containers run on Ubuntu, no problem. Run Ubuntu then. Because the underlying operating system is just different in terms of installing packages, configuring networks differently. Everything else is the same. Because ultimately it's all about managing containers. So using Ubuntu might be more common in work. CentOS is also supported. But in terms of performance, our Ubuntu performs a bit better. It defaults to support Overlay 2. We support Overlay. All right, this is a general concept. All right, get to know this. Did everyone understand? Know that there is such a thing, okay? Especially what we talked about this morning. Our file storage method is a layered structure storage. So we read from top to bottom. And after we modify, it will also copy a copy. Even if the file is 100 MB, it will also copy 100 MB. Not just copying that one file, if you only change one. Sorry, that 100 MB will also be copied up. All right, then next. Next is the image repository called registry. Image repository is divided into 2 types. One is called public image repository. One is called private image repository. This is somewhat similar to Yarn. Yarn has a public Yarn and a private Yarn, right? You connect to the public network. When you install that CentOS, the default Yarn is pointing to the public network's Yarn. All are directed to the official CentOS Yum repository. This is CentOS, right? This is similar to that. So everyone knows it's CentOS's own repository. Of course, we can also do For example, I pointed to Alibaba's repository. Or I pointed to Huawei's repository. Right, I pointed to. These are all CentOS's own repositories. This one points to Alibaba's repository. Similarly, today, didn't BusyBox fail us this morning? Later, using Alibaba's repository stopped the issue. Alibaba also made a mirror site. So, if inside a local network, then does that require every container host to have internet access? Only then is it possible, right? Just like installing packages on CentOS, right? It has to go through the internet, right? So later, did we not learn how to set up a private repository? A private repository. Similarly, we can also set up a private image repository. This is something we'll learn later. The public one is provided by Docker Hub or say some mirror sites, provided by various companies. Hongmao also provides an image repository. Enterprises can also build their own private ones. They can also use Cloud Image Repository Services. It is an open source project. Can build private images. This afternoon, we will use an open source project to set up a private image. There are also public ones, such as Huawei's SWR, Alibaba's ACR, right? You see, cloud image repositories also provide image accelerator features. Haven't we been doing that these past few days? By using them to provide accelerator features. Usually, an image consists of several parts. Several parts. The front part is its name, the name of the image. The back is its tag. Let me explain here. This tag is a human-defined tag. For instance, does HTTP 2.4 definitely indicate version 2.4? What if I just make one up? It might not be 2.4, but generally, we suggest that this label has meaning. 2.4 should represent the version of HTTP 2.4. It indicates this version. You say our 2.4 is actually version 2.0. That's not definite. So generally, we suggest it is meaningful. Don't just make one up. For example, let's look at Apache. When you open HTTP, it's actually version 2.4. See, it's version 2.4. So this 2.4 generally should represent the actual version. Don't just make one up. And this latest usually represents his final version. But this is just a label. Whether it's the final version depends on the author. At the time of writing, was it really, hey, this is the final version? But if I randomly label something, it actually isn't the final version. But can I still call it that name? It works. This kind of convention, we generally assume this latest is the final version. But some folks don't play by the rules. They don't act conventionally. Oh my. A version 2.4. A version 2.5. A version 2.3. They make 2.3 the latest. You download thinking it's the latest version, but end up downloading version 2.3. This guy doesn't play by the rules, no way. But generally, this means it's the latest version. If you download without specifying a version, by default, it uses the latest version, right? We've downloaded it multiple times, like Docker. Pro HTTPD. If you curse and don't enter the version, hit enter. See? It defaults to using the latest version. That's how it comes. It's a conventional practice. All right, I prefer another method. What do you mean? All right, let me give you an example. It downloaded, and you'll often see a feature. The name of your image repository. Why is it this long? I told you earlier, it's the name of your repository, the name of your image repository. This is your organization name. This is your image name. Let's take a look. I log into my Huawei Cloud account. I like this. I didn't understand this before. Why is it such a long string? Later, I finally understood if two people define the same type, which one will download? You can't have two the same in one repository. Why would there be two of the same name in the same repository? It's impossible. This won't happen. All right, look, here's an image. This is a public image uploaded by Huawei. Huawei's uploaded public image. Hong Kong, Beijing. If you want me in Beijing, look at this, my image. Look, this is what I uploaded. This is what I uploaded. My own uploaded image. I made an image and uploaded it. How to upload? There's organizational management here. You can create an organization, just create one. Like here is one organization. I randomly created it. Here's also an organization. The name of the organization, the name of the organization. All right. If today I upload an image to this organization, how to upload? Image. There's a client upload and a page upload. You upload through the page to here, page upload. No more than 2 GB, that is a single image, cannot exceed 2 GB. If larger, you need to use the client to upload. We want to be more professional because in the future, only Huawei and Alibaba like clouds. They provide a web interface, but actually, in open source, there's no web interface provided. So what to do? So use the client to upload. When uploading, because generally uploading is not anonymous, it requires authentication. It's not anonymous, it requires authentication. So here's a command to generate a temporary one, or you can generate a long-term command, like a login command. He needs to log in. That's when you upload coming. Why do you have the authorization to upload? It's not just finding any machine and uploading to your image repository. Generate a temporary one. Copy this. Actually, this username and password are my identity information called Docker login. That's the login. Hit enter. Look, I logged in successfully. See, now I can upload. I have the authorization to upload. Okay, next, how do you upload? Called Docker push. Attach the image name, this image name. You say I'm here Docker push. Upload an image, where did it go? Don't know where it went. So Docker images. Let's say today I want to upload MySQL 5.6 into my own image repository. What should I do? I need to do this. Docker tag MySQL 5.6. Rename it to this name, like this. Tag with your image name and version name. Image name, which is our MySQL 5.6. The following is the Huawei Cloud's Beijing address. Huawei Cloud Beijing address. You should look at different clouds, the address they provide. Otherwise, you need to follow up with your private image's IP address. All images, if you're running a private image repository, then it would be the IP address of your private image repository. All right, next, the organization name. My organization name is my name, Teacher Sheng Lin. So I changed the organization name to the name I want to upload as. What do you want the name you upload to be called? I'll also call it MySQL 5.6. Okay. Now look again. Has your name changed to this? Right? Your image's name is no longer this. Instead, if you default download from Docker Hub, this is Chess's. Chess does not need a path. It is Docker Hub. It's Docker Hub. If it's someone else, they need to connect with their path organization name. Okay. So when you Docker push, attach this image's name. Now, does it know where to upload? 5.6. Hit enter. Because you did a Docker login authentication earlier, logged in successfully, you can now upload. Otherwise, how could you upload anonymously? It wouldn't be possible to upload. We are now uploading. In the future, we will set up our own image. By establishing our own image, we can upload it to our image repository for our use on this platform. All right, let's take a look at my image. Organization management. Click open. Image. Do you see if it has been uploaded? This is what I just uploaded. I uploaded it. In the future, in CC, I can directly use the images from my image repository. That's so cool. That's so cool. Regarding how to set it up, that's what we will learn next. Did you understand this segment, everyone? Did you understand this segment? Did you get it? That's so cool. This is what I want to do. I will set up my own private repository in the future, and this is how I will upload images to my repository. I'm now going to upload to Huawei. How did you upload? Look here. This tells you how to upload, but first, right? Log in. You have to log in. Log in. And then upload. Before uploading, you have to tag your image. This tag can't be random, otherwise how would it know where to upload? So the name of the tag must be correct. It must be correct. Otherwise, how would it know where to push? Okay. So before we finish class today, everyone should have done something like this. Uploaded it to prepare for tomorrow. Tomorrow we're going to use CC1. The same. Inside Huawei's private cloud, there's also an image repository. You also need to upload the image that you've created yourself. Upload it to our own private cloud image repository. Then this address should be changed to your private cloud images address. That should do it. Have you learned it? Good. We have just learned about the layered structure of images. Second, we have also learned about our image and how to upload it to the image repository. Right? Actually, you can also upload to multiple hubs, but the precondition is that you have registered accounts on those multiple hubs. That's also possible. You say, can I place my company's images on multiple hubs? That's possible too. And there are two modes for uploading. One is public, and one is if you don't want it to be public. Meaning, you can choose to make it public or keep it private. You can decide on your own. So you hope to place it here, come here and register an account. You can also upload images to multiple hubs. As for how to register an account here, right? Register an account. In the future, you can also log in and upload images to multiple hubs for unified management. That's also possible. All right then, how to upload via the page is simple. How to upload via the page, just choose. Select the image. Where is your image? Just select it and upload. Isn't that it? Is there any difficulty in that? Many people ask, how do you download the image to the local machine? How do you download it locally? This is what I'm going to talk about next. This pull image. This is tag. Push the image. Push. Here, if through the page upload, how do you upload? Like this. Docker. C. Nginx. Your version. Output to Nginx. Then here, okay, what does that mean? Look, Docker. Images. Docker. Make a smaller one. Just Nginx then. This one is very small. Okay, Docker. Cf. Attach your Nginx. Latest. Nginx.ta. Hit enter. Isn't 140 megabyte this? Isn't it packing the entire image into a file? Then if you upload this file, isn't that enough? Then here, do you understand? Okay, then Docker. Images O, delete. Docker images. Many people ask why it hasn't been deleted. Why does it turn into two nuns here? Generally speaking, this can't be deleted. Why can't it be deleted? Because you still have a container using it. Once you have a container using it, you can't delete it. Even if you delete it, it's just a deletion marker. Here it will turn into none. So some people ask, in an interview, they ask, why does this image here turn into two nuns? What does that mean? It means your container is still there. The image has been marked for deletion, called untag. In reality, the image itself is not deleted. It is not deleted. Do you understand? Unless you delete all the containers, all those related to it, not all containers, but those using its image, delete them. Then you come back, Docker, RMF, no. Image, RMF, how to delete now? This time you need to delete by ID 605. You see, is it really deleted now? Okay, now suppose I want to delete another Docker image RMF HTTPD 2.4. Enter, you see, does it first untag? Is it deleting now? If someone is using it, it cannot be deleted. No image is using it, it is deleted altogether. Docker image, and just now, wasn't it already saved? So Docker loader, tar Docker. Images, is it back now? Is it back? Just now it was gone. This time save the image, save it into a file. Now have you loaded it over? Load. Is it back to being a normal image again? This is unnecessary. Saving and importing images. Do you understand? You have to take the image. If I make an image and I want to give it to you, do I not pack and send it to you? You just import it. Now, when you upload through the page, isn't it just finding the file to upload? Isn't it just like Docker loader to upload the image? It's so convenient. Do you understand? Did you understand? Understood. Similarly, if today I have a container, you can also save the container, save it, attach the container name. Oh, save the container out. Is it now elsewhere? Export the container to another place. So backing up and restoring containers is also very convenient. Backing up and restoring images is also very convenient. So cool. If today you save an image, a container is also very convenient. It's very convenient. You can also save 042. Oh, you first have to save it as an image. First save the container as an image, then export the image out, export the image out. How to make it into an image, how to turn a container into an image. That's what we're going to learn next. This is deletion. Okay, this is how we are going to make images next. It's somewhat similar to how we make glance images in OpenStack. Okay, we take it slow. Can we move on from the previous parts? Did everyone understand the previous parts? We are starting now. This part might take about an hour. We will learn how to create images. Is that okay? Can we move on from the previous parts? Is that okay? Okay, let's calm down. We're starting to make images now. Does anyone else have questions? How to upload images? How to download images? How to package images? How to restore images, right? We just learned how to upload them to image repositories. Did you understand this process? Okay, let's take a sip of water and get ready to start. Here's the thing. There are two methods to make images. The first and simplest method is called Docker commit. It allows you to commit changes or images to create a copy that forms a new container. For instance, look here. It shows Docker images with an image called NGINX 1.21. Here, next through NGINX 1.21, a new container is deployed. Right, a new container is deployed. Finally, I made a modification in this container. You see, I changed something. I modified its content and then exited. After exiting, isn't it a Docker commit? What is BD? It's the name of this container. Isn't it packaged into a new image name? Isn't it essentially turning a container into an image? What does it mean? What does it... Look, Docker execute 042 bin bash, then enter USR share ng and HTML. It was originally like this. We take a moment and then it's hello, CC1. Did I just change the content to CC1? Exit Docker commit 042, packaged into a nginx Weibo, version 1.0. Docker images, is there now an image called nginx Weibo? Look here, finally, can you use -- name? My Weibo zo1 through nginx, isn't it enter to deploy a new image? Isn't it deploying a new container just fine? Isn't the new container's content now just like the recent hello CC1? Just the recent content, do you understand? A new image has been formed here. You see, isn't it the content of the new image I just made? Isn't it just what I produced? Did you understand this step? After I made the changes, didn't I generate a new image? Am I not saving this image out? I go to another machine, run. By running the image, isn't it essentially moving the container from one machine to another? From my machine copied to your machine? The steps are customizing the image. There are two methods. The first is through Docker commit. For example, through a general image, create a container. Then in the container, modify content. Third, repackage into an image. How to do it? That is Docker commit. Attach the container ID. Then attach a name for the image and then run Docker images. Next is to run Docker with DP, arbitrarily, P88 or 80. Name, mywebzo1. Are we deploying with the new image? This should work, right? After processing, then converting it into an image. Can this also be done? Docker C5, attach with O, package it into one. Can it be done this way as well? Save. This is the first method of customizing images, called Docker commit. Did you understand? Everyone, is it clear? You buy some raw materials yourself, process them a bit, and isn't it like creating something new to sell, right? Okay, good. But this method isn't very flexible. For example, if I now make some adjustments, can it be adjusted? I also don't know how this image was made, so I'm quite afraid. I don't know if this image is safe. I'm not very keen on using it. That's the first point. Secondly, if I need to make adjustments again, do I need to reshape a container, change, and package it again inside the container? It can't maintain consistency, or say, it can't replicate this process. It's not very convenient. So generally speaking, in a production environment, this method is not widely used. Instead, people write a Dockerfile and compile it using this file. They build the image through the file, which is a common industry practice. This is the industry standard practice. Now, Huawei's HCIE, whether it's for cloud computing HCIE or cloud services HCIE, requires in the exam to be able to make, through a Dockerfile, an image, a customized image to meet their requirements, are requirements in the exam. to make a custom image that satisfies their needs are required in the exam. Good, how do we customize? We need to write a Dockerfile. A Dockerfile is a text file containing a series of commands. These commands can build a container image. It starts with a hash mark. We can build images with Docker build images, or say Docker build with. F to specify a file to build. Then T can specify tag when building the image, its name and version. So usually we start learning how to write a Dockerfile to build an image. Typically the first line of a Dockerfile must include a from. The front must be capitalized. The front must all be in uppercase. From represents your image, its base image. It is based on which base image to build. It could also be official, or Debian, or CentOS, based on which version to build. The second sentence is the image description information. Optional. This sentence can be omitted. It can be left out. The third line is env for environment variables. Set some environment variables for it. The fourth line, run. Run. Between commands, use two ADD symbols to represent. These two ADD symbols mean that if the previous command was successful, then the next command will execute. When this command succeeds, then this one will run. When this succeeds, then this one will run. When this one succeeds, the next one will execute. You see, until completion. Many say, what if the above command was not successful? Then it will not execute the next command, because this command was not successful. Executing the next command would be meaningless. Thus, this is a Linux command, like LSL, two ands, CP, call to temp. It's executing the first command. When this command succeeds, it will execute the second command. If the first command was not successful, it will not execute the second command. For instance, you see, this directory does not exist. When this command succeeds, only then does the next command make sense. If the previous command did not succeed, the next command is meaningless. It's meaningless. Did it execute? This is the double end. You can append a number of ends. No. As long as needed. There's no limit, you say. Can I add a number of ends? Yes. So run is just a command, signifying that I want to run specific commands, separated by end in the middle. Why? Not to execute multiple runs, because each instruction, these instructions are all Dockerfile commands. All Dockerfile commands. Why not execute multiple runs? Each command is a run, because this would create many layers. And the more layers there are, its container. The image will be larger. It will be larger. So try to keep this in one line to represent. Good, of course. You say these two lines. Run. Can it also be included in this? It is possible. But these two things, what was done above, is completely different. It's better to write two runs. Better to write two runs. Is it okay to write in one run? It is okay. This is what we call exposing the Berlin port. More on that later. More details later. This is the command. Good, generally. Before making a custom image. First, from a base image. If many say, I want to start from scratch. How do I build an image from scratch? This indicates, you see, when making an image, usually starts with a base image, then modifies it extensively. We call this the base image from, and this image is a special base image. It's a blank image. I want to start from scratch. If I from Debian, from CentOS 7, it means it will start from the CentOS 7 image. Good. I build in the Red Hat directory. I create a new one here. Dockerfile. It's best to call the file Dockerfile. Is it okay not to call it that? Case is strictly distinguished. Is it okay not to call it that? It's okay, but if you call it that, the system will automatically read this file. You named it from CentOS 7. Once you start building, if you haven't downloaded this image before, it starts by downloading the image. If you just use this name, it represents a blank image. Start from scratch, build from zero. For instance, many CentOS 7. How was that image built? It started from zero because it had no base image. So look how others write their images. For example, CentOS 7 here. Good, you click open, push, tag. Now it's 6. I'll just search for CentOS. CentOS, look, it has CentOS, click open. This tells you how this image was made. Do I have a Dockerfile? How each image was made on Docker Hub. There is information about how its Dockerfile is written. Look, CentOS 7, CentOS 7.9. How is it written? Look, I open it. Look, is it not started from scratch? Building this image on its own, see it? Building this image on its own, actually it's also an unpacked archive. Live is an explanation. Then run. So the advantage of Dockerfile is it's transparent. I know how this image was made. For example, MySQL. Click MySQL. You want to know how the MySQL 5.7, this image was made. It has versions based on Debian, versions based on Oracle. How were they made? Good. I remember the Oracle version. Oracle is based on Red Hat. Modified from it. Its base is, you see, originates from Oracle Linux 7. Starts running, adds a user called MySQL, right? Adds a user named MySQL. Its joining root is here. This part, how it was made, it runs which commands. How was the MySQL image finally made? Up to here, all commands, good. So the benefit of Dockerfile is it facilitates future modifications. Firstly. Secondly, it's transparent, letting those who use my image feel at ease. They know how I wrote it. Go to File. You can go and download. Look, you can download these files. Everything needed to build MySQL. I can find it all for you. Here, you can download everything. This is about building Dockerfile. Today we are going to learn how to build a Dockerfile. Many say these commands are annoying. So many. Will I manage? You can do it. It's simple. Just learn Linux. As long as you learn Linux, as long as you have a solid foundation in Linux, we can handle it today. That's why I always emphasize learning Linux well. It's for this reason. Today, it finally comes in handy. Okay. Next, there are many commands here. Many commands. Okay, let me start. I will explain each one. Okay, today I will use CentOS 7 as an example. From CentOS 7, I take CentOS 7 as an example. Okay? As its base image. Okay, today I want to make an image like this. I want to make an image today that can be accessed via SSH and where I can also check the IP address. Because the previous packages weren't installed, I can also execute the ping command and use the VI editor to edit files. I want these features. Today, your images cannot be connected via SSH because the SSH service is not turned on. SSH service is not on. You hope to use SSH service, then during the image build, you need to turn on the SSH service. How to turn it on? Okay, one by one. Do you all understand? Today's goal, do you all understand what I'm doing? Is it okay? I use CentOS 7 as a template, as the base image, to build an image with these features. Is it okay? This is my goal. That's it. Okay, first of all, from comes from CentOS 7. If you don't add this 7, it's latest. You say, can I add 8? That works too. Scroll down. You can, for example, I particularly dislike, what's it called? Using CentOS's own source. It's particularly slow. I want to use Huawei's source, Huawei Cloud source, or Alibaba Cloud source. How to do it? Like this. You want to use Huawei Cloud source. You need to do this here. Cert YAML. Huawei Cloud also has a mirror site called Mirrors. Huawei Cloud, just this, report Huawei Cloud, cloud.com. It also has a Huawei Cloud, also has a it has a website called Mirrors Huawei Cloud, cloud.com. There is such a website. This is Huawei Cloud's mirror site. Among them, there's CentOS. See, Ubuntu, look, all sorts are available. We find CentOS. Continue using. Look at his YAML here. He says, come you want, I want to use CentOS 7. Your YAML source can be downloaded like this. Can be downloaded. Okay, I'll download it first. Where to download? Usually, we download it locally. Let's open it. Where did it download to? It downloaded to my local machine. What's this? That's not right. It downloaded here. It downloaded under my Red Hat directory. You see, am I opening his file? Is it all pointing to Huawei Cloud? They all point to Huawei Cloud. Now it would be best to change the name. CentOS base, or it's fine not to change it. So in the Dockerfile, add what? If no path is specified, it means files in the same directory as my Dockerfile. If no path is specified, it means files in the same directory as my Dockerfile. Copying to, I named it Huawei Cloud.ipo. You know, this sentence means, am I copying this YAML source here? Name this, right? I don't want to. If you put the download action here, I don't recommend it. Because if you put the download action here, every time you build the container, won't you need to download it again? Should I put it in one Dockerfile file? First download it. Should it not allow? To make the build process do as little as possible. Okay. Did you understand the first two sentences? Especially the add sentence, did you understand it? Add, did you understand? Because it's CentOS, so I'm essentially changing CentOS's source to another. Did you understand? Did you understand? Do you know that firm? Does CentOS still need to connect to the internet? Yes. Either you have already downloaded it locally, or you need to connect to the internet to download it automatically. Okay, next, let's start running. Generally, when you see here, there's a function, look at someone else's script. Why is there always a, what does set X mean? Actually, you don't X, then you write again. It's not necessary to write this. This will help you output logs. During the running process, it will help you output logs. Did you understand? Output logs. So I run like this, and there's another function to do. mk, etc. yum, d. Downloaded, back, move, downloaded. I want to change the yum source. You don't have to change. It's okay. Do you know what yum sources are? Aren't they all starting with CentOS yum sources? Why did I just change the name? It's because of this. CentOS. I see uppercase OS. Strictly case sensitive, move it to, etc. yum repos.d on the back. Do you know what this sentence means? Actually, this step can be omitted. I can just use CentOS source 2. I just copy this file over, rename it to this, and isn't it moving the original? This folder called back, moving all its original sources into it. Got it? This way it won't use the original sources, right? Otherwise the original sources would still be there, right? Clear the cache. Then, yum y install. Make sure no interactive interfaces appear during the writing process. Interactive interface. Okay, it's OpenShift server. That package, huh? The SSH package is called OpenShift server. Then there's NetTools for the ping command and ifconfig. Many people ask, how do you know this? You see, is it this package? And if you need the VR editor, the more stuff you install, the bigger your package will be. Your packaged image will be larger. You can install multiple packages at once. This time you can. Simplify if you can. Okay, next it's like this. Once you've installed this package, you need to apply for a certificate. Let me explain this command. Because SSH needs a certificate. Let me show you what A means. A. It will automatically generate this certificate for you if it doesn't exist, and place it in the default path, and the password is empty. It's like when you SSH. Normally when you generate a certificate, it asks you. This doesn't ask A. It will automatically apply for the certificate for you. Isn't there no interactive interface? If there's no certificate, can't people connect? Isn't this the method to apply for a certificate? If there's no certificate, they can't connect, right? So this command is a method to apply for a certificate. Everything must keep the interaction non-interactive. Okay, this time, let's do a lot. Let's do a bunch. As much as possible, let's do it together. Don't have multiple lets. Unless what you're doing is completely unrelated. You can have multiple lets. It doesn't have to be just one let. Okay. And the container by default has no root password. I'm going to create a user here named Teacher Sheng Lin. Then, after creating the user, set a password for this user. Don't have an interactive interface. Do you know how to set a password? It's like this. Setting a password is done this way. But this has an interactive interface. So there's a function like this. Isn't it said that there's no interactive interface for the password? The password is directly set successfully. This is the function of the password command. It means I created a user. I created a user. In the future, I can log in with this user. And I know his password. Okay. Later, we'll add some features. We'll talk about that later. First, let's package it up. But we still have one last thing. Containers are born for tasks. You'll find that every container actually recognizes a script. Do you see? It's because this script keeps it running. It's because this script continuously keeps it running. When you enter this container and open this, it actually runs this script inside. This script inside here might just be running some service or something. This script here may just be running some service. Okay? Like this. Do you know what the principle is? when you start an SSH service? What is the principle when you start this service? Actually, it calls something called user level system down the system. There will be an SSH, first point service. Actually, whenever you start a service, essentially, why do I say this? Look, disable SSHD, disable SSHD. It actually just deletes this file. Then you come back, enable. It's actually like, does it help you create a shortcut to this file? So, is the real service this file? Right? Every time you boot up, why does this service start automatically? Because it reads this. And here it actually made a shortcut to here. Many people ask, how do you know it's this? Is the shortcut pointing here? Is this where the real service is? Every time you start a service, systemctl actually reads this file. And this file actually has a shortcut pointing here. Okay, next, I'll open usr lib system ssd.service. Actually, I'm telling you, you read all of this. It has many dependencies. The most important point is, it actually executed this command. Actually, you say 1,000 words. Eventually, a key was generated. When you start the service, it generated a key because this script worked. There's a service here specifically for generating keys. Okay, I'll find it for you. sh. Where is this script? I'll find it and show you. I'll find where this thing is. Also here. shd. What is the command to generate keys? You see, isn't it using this command to generate keys? See? Okay. Open it again. Actually, ssd essentially runs this command. It essentially runs this command. So this service starts up. You don't believe it? Try running this command. Just run this command. It actually just runs the service. Your SSH relies on this service to start. That's simple. So here, the way it's written, you must pay attention to how it's written. It's written like this. USR SSD, comma. Its parameters. D is written like this. If you write it this way, it means this command represents that each time you run the container, it will automatically load. And once loaded, the container won't die. It will continue running. Okay, especially the last sentence. I will come to explain later. Command. What is command for? It is used during container construction to set the command that the image executes when it starts. When you build it, add a parameter. Once you run the container. Once you run, doesn't it execute this command? What is the result? What's inside here? Isn't it hello cc1 you see here? Inside here is hello cc1. Kite. Check this content. It means when you run the container, isn't it executing this command? When is this command run? It's executed when running the container because of this command. So your container is continuously operational. It won't die. Your container won't die because containers are born for tasks. You let this container run, continuously executing this. This thing is running in the background, right? The container won't end. Many people, how do you know it's this command? Haven't I taught you how to find out? How was it found? How was it discovered? Because it actually runs this instruction. Everything else is there to assist it. Ultimately, it's about running this service. So I just run it in the container. This container will then monitor port 22. That's the idea. So what about installing? and starting services? What makes them start automatically every time? Ultimately, you just manually execute this command. The rest are just supporting services. The rest are to allow the system to manage it uniformly. So a file like this was written. Actually, this one line of content is enough. That's enough. This is crucial. Do you understand? This is especially important. Containers are born for tasks. They must have something to do. Have something to do. This line is about listening. Let the service listen in the background. Let the service continuously listen in the background. Continuously listening. So this process won't die. If this container won't die, if you don't add this, the container, it ends as soon as it runs. Because every time it does. Because every time it does. Right? Just like I showed you. Docker. Run. D. Then. Name sent OS 7 Femi 7. Sent OS 7. Did the container run? It ran. But has it already ended? Has it ended? Because every time it does. Every time it does, it ends. It ended, right? Okay. So now, I just wrote 1 line, 2 lines, 3 lines. This whole thing counts as 1 line. 4 lines, 5 lines. Is it only 5 lines? I did a lot of things. Okay, enough. Just write these 5 lines. Start with Docker. Build T. T is for tag. OpenSH 1.0. 1.0. My image is called OpenSH 1.0. Current directory. It will read the Docker file from the current directory. If your name is not this, if it's called ABC, you need to use FABC, followed by your folder, or the current directory. Attach the current directory. Now, if you don't follow anything, it will default to reading the Docker file, the file inside the Docker file. It will default to reading from the current directory. Let's build it. If not written, it defaults to bin bash. Okay, now the image is being built. The image is being built. Docker build T. OpenSH 1.0. You see it's building the image. Is it installing packages? It means that after the image is deployed, are the packages installed? Is the user created? No errors. Finally, your image is truly built successfully. You see all 4 tasks are done. Docker image. Finally, there is an OpenSH 1.0 image, over 400 MB. Later, we'll learn how to optimize it, how to optimize this image. Now it's 472 MB. We'll optimize it later. Okay, let's not worry about optimizing it for now. Let's get it running. Docker run DP222, listening on port 22. With the name, my server 01. My built image. My own made image. Cherish it. Docker PS-A. Is it continuously running in the background? This one hasn't ended. Hasn't it ended? Okay. SSH. From the outside. SSH 192.168.2.57. P 22222:22. Cool. My username. Password. Did I log into the container? Is it okay now? But there's no root password for the container. You don't know the root password. You can't switch to root. What to do? Here. Docker. exec et. Enter 6b bin bash. Not this one. Docker PS-A. It's this one. This 068. Password. Directly set a root password for it. I enter the container. You don't need a password for this command. You don't need a password for this command. It's a local container. I'll try again. Root. Run hard. Cool. Check the other containers. See if SSH is listening. It's not listening. I am listening. I can also check IP. I have VIP access. Cool. I got everything you wanted done. Ping. 172.17.0.1. We achieved our goal. We achieved it. Did we achieve the effect we wanted? Did we write a Dockerfile? We built a custom image. How about that? I first wrote 6 lines. Keep it simple. We'll expand it tomorrow. Because today the timing wasn't right. It's best to finish it all at once. No worries. Today, let's give it a break. We'll continue to discuss this topic tomorrow, focus on it, and continue to expand. We've written these few lines. Let's get it running first. Regarding this, we'll talk in detail tomorrow. We'll talk about this feature. Okay, we build it with Docker build. Later, if I add some features, like here, workdir data, here, besides mkdir. I also make it create data inside the container, then workdir add data. It's best not to do it this way. It's best not to do it this way. We'd rather do it below. Each has its pros and cons. Each has its pros and cons. We'll do it here. I add a workdir data. This time you should mainly rely on build T. OpenSH 2.0. Actually, this is not a good practice. You see, it's installing again. Didn't it just install? Why install again? You don't want it to install again. You shouldn't have written it that way just now. Okay, Docker, images. Is there an OpenSH 2.0 now? Right? Okay, our Docker, run D2200, 2.0, P, name my server .2, OpenSH 2.0, retract, then Docker, exec, it, 8002, bin bash. Does it default to entering the data directory? That's what the workdir does. Today, I don't want to focus on workdir. The point is when we should build it into 2.0. Is it because I want to add some features or fix a bug? Should I then build the image into 2.0? Right, is there now a version 1.0 and 2.0? If I really only have 2 versions, should I mark it as latest? If I have a 3.0 in the future, should I change the latest to 2.0 and make 3.0 the latest? Understand? Where does it default to? Same as yesterday. Docker. Where does this image default to? Same as always. Images. Docker. Check 9DC. Here. Your image still exists here. Also here. So, at the start, you should specify where to put the image. Same as always, it will also be placed on the WebLab Docker. Got it? Okay. Someone asked, can you specify multiple port mappings? Of course you can. How do you do that? If needed, why not? For example, in your Dockerfile here, you should install packages when you should have HTTPS installed. Then when you start, shouldn't you have the SD service started? When you build, isn't there HTTP running and SH running? Let me give you an example. At this time when you're building, Docker run DP222 map 22 P8080. Isn't it mapping 80? Doesn't it mean mapping 2 ports at once? Do you understand? CMD cannot write multiple lines. Once you write multiple lines, only the last one is effective. So you should use commas to separate. You can write, but only the last command is effective. See that? The specifics we'll talk about tomorrow. So just understand this. Many people ask, where was this FNS7 used? Look, we're here. Logging into this container. Isn't it using CentOS? The commands you use to install packages. Aren't they all CentOS commands? Look, isn't it a CentOS system? But if it defaults to Debian, the system you enter, is it a Debian system? Do you understand? Good. BusyBox is only a few megabytes. It's not just a few megabytes. BusyBox is only 1.24 MB. Not just. Why is this BusyBox so small? WordPress. These are standard. Look, others have made them too, and they're 2 to 300 megabytes. This 1.24 MB BusyBox. This BusyBox of 1.24 MB. Why is it so small? How big is my SH? Over 400 MB. Actually, it's okay. Of course, there's room for optimization. Can I make it even smaller? Of course you can. Of course, it can be made even smaller. I'll just make a small change, and it will become much smaller. At the end, maybe you need to optimize it a bit, delete things that can be deleted. I'll rebuild it for you. I'll just modify it a bit. And you see, isn't 3.0 just 287 MB now? Just by optimizing a bit, hasn't it reduced a lot? Is there still room for optimization? Of course. If we hadn't grabbed those explosive packages, do you think it would be so large? Again, actually these packages, I actually only need to install these packages. Actually, these packages are not needed. What are they installed for? These packages are not needed. Right, look, I'll do it again. 4.0. Look, let's check the images again. Isn't our 4.0 just 231 MB now? Small enough, right? And I'm based on CentOS 7. Look, it's originally 204 MB. Isn't mine just 231? Actually, it's just a little bit more. If not going with CentOS 7, I could use Debian or Ubuntu. Wouldn't it be smaller? The optimizations I can make are just over 100 MB. I've been sincere enough, right? Otherwise, start from scratch. Starting from scratch would make it even smaller. Then it would be even smaller. Okay then. Did everyone understand? Did you all get it? There are many ways to optimize. We'll discuss them in detail tomorrow. From now on, you will also learn how to build images. You'll also know how to build images. Starting from scratch is much more complex. It's much more complex. Yes, starting from scratch is more complex. Others starting from scratch aren't really starting from scratch. They also have they also want to start from scratch. For example, let's say I want to start from scratch, truly starting from scratch. But do you see? They downloaded a package. This package likely contains most of the essentials. See? This package likely contains most of the essentials. That's right. Generally speaking, it's not necessary. We don't need to start from scratch, because starting from scratch is too complex. We just build from a base image. Start from a base image. So, we've also learned how to build. Starting from scratch isn't just about source packages. He probably pre-packaged a large file, then unpacked it. Most things were included. Actually, just open the zip file and see what's inside. You don't need a source package. It's troublesome. Source packages require compilation. You need to learn how to compile and install. That's too troublesome. Okay, this is simple. We'll discuss these details in depth tomorrow. Okay then? We'll talk about this in detail. Finally, everyone has learned how to build a custom image. Okay then? What do you think? Isn't it cool? Tomorrow I will teach you more advanced features for building images, so everyone can build images very smoothly. Okay then? Isn't it handsome? Isn't it cool? All right, it's simple. I'm particularly sleepy now. No more additions today. No more additions. Let's keep it simple. Isn't this how you write scripts? How do you normally write commands? Isn't this how, right? How do you usually do it? How do you type commands? What function do you want to achieve? Just do it the usual way, right? Okay, no more teaching today. If you're not familiar with commands, get to know Linux well. I've already supplemented all the commands we need for IP, right? You need to understand the IP knowledge. If these commands are unfamiliar, then there's nothing to do. This is the foundation of Linux. I've supplemented IP for 4 days. You've copied all my lessons. How come you still haven't learned? This is simpler than HCS. Teacher Dung. Yes, that forum. It's from Docker's configuration, loaded from Alibaba Cloud, starting at 3,200 at least. Yes, exactly. Just downloaded from your image site. It's just like you executed this command. The reason I didn't just now is because here I have a CentOS. See? If I replace just now with Ubuntu, there would be a process to download Ubuntu. Right? Then it's about adding that CentOS, then adding to the image's position, adding into the image's file. Because all this is done while building the image. Just taking my local file and copying it into the image. All these operations are done inside the container. All done inside the container. This is just a bit of basic training. So, I also made sure to prevent you from not understanding, so I spent so much time on IP. I told you to do the commands and spend the time. I guess many people didn't do it. Those 4 days were wasted. So in the future, why bother supplementing if you won't bother? All right, let him cool down today. Tomorrow we continue. All right, tomorrow we continue. Tomorrow we still have to write Dockerfile. If you don't understand the commands tomorrow, it'll still be painful. Writing that Android script is much simpler. Yes, because we start from CentOS 7. Those who make CentOS 7, how do they do it? Are they starting from scratch? Right? Because we start from CentOS 7. So how did the people who made CentOS 7 start? Right? Because we start from CentOS 7. So how did those who made CentOS 7 start? If they started from someone else, who is the top layer for them? Are they starting from scratch? Starting from a blank image, layer by layer built up, right? That's why there are layers in the image, right? Like my current image, isn't it also layered? Why? Because I started from 7. Didn't I add another layer? Right? So it turned into several layers, right? As long as you need a script, write whatever you want, even loops or conditional logic, it's all possible, right? In the CMD, if it's, for example, cat, it will keep executing cat, run it once, and then it ends. It ends because this command runs in the background. It won't end. If it's cat, it runs once and then ends. D stands for detached. It's run as a service in the background. D is the meaning of running it as a background service. It's the function of the SD service. This is the functionality of the SD service. It's not the functionality of SD. It just keeps monitoring SD. Okay? Okay? Is that okay now? Is that okay now? Okay, everyone, that's fine. That's all for today. Next time I'll give you my domain name certificate. ChinaOpenAI.com. Give it to someone deserving. To someone as diligent as you, I'll give it to you. Okay, everyone, goodbye. Goodbye. See you tomorrow. Okay, everyone, see you tomorrow. Okay then, the rockets are flying up. Those who understood today's content can still manage one for themselves. Get another drumstick, right? Okay, I'm done. Okay, thank you.